Hello, now we are going to see the demonstration of a vegetation change detection analysis using remote sensing and GIS. And here we are going to do the spatial modeling, and we are going to use the tool that is the classify using machine learning. So for this we are going to use the ERDAS imaging as our software and the ArcGIS Pro for the creating training samples. The methodology for this is the collection of data. Then we will pre-process our images. Then we will create training samples. Then the machine learning algorithm. Then we will do the spatial modeling. And in the last, we will find the results and do the analysis. So let's move towards the collection of data. So we can collect the data, that is the satellite images of area on which we are going to do the classification from the ISRO Bhuvan website. So here we are going to select the this tile, which is a Sangli city and its nearby area, and we are going to download the 4 bands. We can also download the data from the USGS Earth Explorer site. So we have downloaded the area already. So here you can see this is the band 2 data, this is band 3, band 4 and band 5. Now after collecting this data, the next step is the image pre-processing. So we have to combine all these bands and form the layer stack. So for this we can go to this raster tool in the ERDAS imaging. We can go to the spectral, and here is the layer stack option. So here we have to select the all the bands and then add to this area, and we have to give the some output file name. So I have already layer stack, and after that we have to click the OK button. So it will process and create a layer stack image. So we have to open that layer stack image. So I will open here. So this is the layer stack image of the tile. So now we are going to do the FCC of this. So here I will choose the IRL list 3. So I have downloaded the data of IRS list 3 sensor, and I will do its false color composite. So here the red portion is showing the vegetation, the dark portion is showing the water, and remaining portions are showing the barren land and the built up areas like this. So after this, creating the layer stack, we are going to pre-process our image, so we can do the image enhancing. So in raster there are, in the radiometric there are many tools like haze reduction, noise reduction, histogram equalization and many more, through which we can enhance our image. So after this we have to go to the ArcGIS Pro software, where we are going to create the training sample. So here in this image we can go to the imagery, and here in the classification tools this is the training sample manager. So image classification and the training sample manager will open on the right side. So here this is our schema, and below are the listed classes in which we are going to classify our layer stack image. So we can add the classes using the right click button. So I will add the barren land. I have already added the 3 classes, and I will give its color yellow. So these are the classes. Now suppose we want to create the training sample, then we have to click one of the class, then we have to select the one shape. So I will select the circle, and then we have to go to the circle and draw the circle. So here the one sample is added, then a second sample, third sample, likewise here is also water. This is the 4 samples. So likewise we can collect so many samples. The more samples are, the more the accuracy is. So we will then combine this all the samples. So likewise we do the training samples for the other classes also. So I have already created the shape file. So the after creating these samples, we have to click on the save, and it will create the shape file, which is the vector data, which will be used by us for the training data. So the next step is the selecting the machine learning algorithm, so and the spatial modeling. So here is the spatial modeler which we have built. So these are all the operators which are going to use. So the first one is the feature input. So here we are going to provide the vector data, that is our trained data, which we have done in the last step. Then here is the raster input. It is the layer stack image on which we are going to do the classification. Then here is the raster statistic for feature, where we are going to calculate the mean. So if we click here, so here the compute mean is the true, and also the compute standard deviation is also true. So it is not mandatory to compute the standard deviation, we only require the mean. Then the next one is the select attribute. So here we are going to select only required attributes, like many available attributes are there, like primary key, blue, green, standard deviation, and out of this we need only the four means of four classes and the class name. So we can select this using this right shift and left shift operator. Then the next one is the initialize random forest. So this is the algorithm of machine learning which we have used to create the trained classifier. So here we are going to classify using the class name. So here we can select the one attribute, that is the class name. So through this algorithm we are going to create the machine intellect output, which will be provided further to this operator, that is classify using machine learning. So we have not used the output in between, like we can also use the machine intellect output in between this, like this, and we can connect this to this. So we have deleted that process and just joined the output to this operator. Then in the classifier using machine learning, we get two input, that is the trained classifier, which is in the machine intellect output, and again the layer stack image as a raster input. So this operator classify the image and will produce the output image, which is the classified using machine learning. So doing all this, we can select our input data here, that is the trained data. Then we can select the raster inputs here, and here we can specify where we can save our output file, and after that we can run this model. So we get raster output data after all this. So I have run this model earlier and I have the output data as this. So this is the classes. Now let me show you the attribute table of this. So this is the attribute table where the four classes which we have given in the training data are here, that is the water, vegetation, built up, and barren land, and its corresponding histogram values are also given here. And we have given the colors, like for water we have given the blue. We can select also the other colors. So for vegetation we have given the red color, so it will represent the vegetation in the red color. So this is the histogram, we get the histogram values. Now we want the area, so for this we have to reproject this tile on the earth map. So for this there is a tool reproject. So after clicking on reproject we will get another window. So this is the window. So we have to mention here our classified file, then we have to mention the output file, then we have to select our zone. So I'm in the India, that is my zone is UTM WGS 84 North. Then we have to select the projection, so I will select the 43, and then we have to click on OK. So we will get the UTM data of our. After that we can go to the table, and this add area, after clicking on add area we can select the area in hectare, acre, or square kilometers, and the new column will be produced in the attribute table as a area, and it will show the corresponding area of a barren land on this tile, and the corresponding area of a built up vegetation and water on this tile. So I have done this UTM projection, and here is the result. Like I have performed all the steps till I have mentioned on the two images, that is the image of 2014 February, and you can see that on the left side, and the right side image is of February 2019. So you can see the change, that is the vegetation is decreased, the vegetation is showing in the red color, water in the blue color, and the in the gray color, that is the built up area, it is also increased, and the barren land is decreased in the yellow color. So we can see the result by clicking on display attribute table. on the layers. So here we can see the areas of both. Like if I uh, open the attribute table of the February 2019, so here we got the result. Now let's see the our result. So I have exported the data here on the txt file. So here we can see the change, that is the decrease in barren land, increase in the built up area, decrease in vegetation and water. So for this I have calculated some, got some data of rainfall. Like we have selected 2014 and 2019 data of February. So in 2014 the rainfall is 642.8, and in 2018, like we are considering February 2019 data, so we will consider the rainfall of for 2018, so it is 485.6. So the rainfall is decreased, that's why we can say that our water is also decreased. So this is all about the vegetation change detection using remote sensing and the GIS, and we have implemented the machine learning and the spatial modeling. So thank you.